Good morning, guys. Just wanted to do a quick video on how to connect to the KE2. So I'm going to get started. First, we're going to go over some of the stuff that's actually on here. KE2 itself, RE2. Looks something like this. Here's where the power connects over here. Fan relay here, which is actually right here. You have a display right here that connects to one side of the KE2. If you look, it actually connects right here. The Ethernet plug right here is where you would connect if you were connecting to some sort of EMS. We connect this up right here, you'll see the display light up. And right now it says defrost term on time. That means it actually didn't hit the actual termination temperature. If you were to hold these two buttons, the back button and the right arrow key at the same time, now it actually says Wi-Fi on. So now we can actually connect with our computer or with our phone using Wi-Fi. This is basically for me, so I can simulate temperatures. I have a off switch for the, just turn the thing off, like almost like a door switch. Some of the, that's connected to the digital input, the auxiliary one. You have your coil temperature, suction line temperature, and then you also have the room temperature. And then I also have a pressure transducer connected up. It's not a pressure transducer, I have a potentiometer hooked up to simulate the pressure. And I'll show you that in the next part of the video. So we're going to show you guys how to connect to the KE2. What we're going to do is come down here to our Wi-Fi. Now you saw that I already pressed the back button and the right arrow key to turn the Wi-Fi on. Currently it is on. You can tell because there's your RE2. So I'm going to double click on that and hit connect. Now when you do that, it's going to populate a window. Come on. And there is what we're looking for. After logging in, open up your browser, or you can just hit log in. If it doesn't redirect you right away, just hit click here. And as you can see, we actually have temperatures. I have my magic black box hooked up. I think I have 10, maybe 100K ohm potentiometers, so I can simulate temperatures and pressures, and so it actually gives you an accurate superheat. Now, if you see right now, the system does say off. That's because I have the auxiliary for this actually programmed as an off. So when I hit the button, whether I could basically make it a shutdown button or a door switch, see the liquid line solenoid's off, the fan is off, the EEV position is in 0%. But if I do hit the button on the magic black box, see right there, system is on. Liquid line solenoid came on. I don't know if you heard the click, but I heard the relays click for the evaporator fan motor and the liquid line solenoid. As you can see, the EEV position is starting to increase. I think I have the temperature set for -5, I believe. 0 -5, I'm not sure. And I have the superheat set for about 5 degrees. So this is going to be the range that it's going to try to maintain if this case was live and out there in the field. I got to do it real slowly because these aren't the most accurate potentiometers in the world, but you'll see as I start turning, so the coil temperature is starting to go up. That's just basically going to be for fan control as well as defrost termination. That's what that one's going to be used for. This one right here is going to be my room temperature. As that starts coming down. Superheat still is currently at 8 degrees, so we're going to try to start turning that down a little bit. And as you'll be able to see over here, you'll see that the EEV position is trying to clamp down a little bit because we are maintaining the approximate superheat that we're set for. If I do click on here, you'll see the superheat is set for 5 degrees. I have it set for an SER AA valve through L, so it gives it 2,500 steps. And this is where we can actually increase and decrease how fast this thing's going to run. If I want to see if I could try to increase this a little bit, I don't know what their range is as far as the derivative. I don't know if it goes all the way up to 100. I'm going to try it. Username and password is KE2 admin. I'm going to post that in here. You'll see that up in the upper left hand corner. And log in. And you see the EEV position is starting to come down a little bit faster than what it was prior. It's because I increased the integral time. Usually the lower number, the slower it reacts to time. So that's the way that works. PID is one of those things that no matter how many books you read, and it's all about learning and playing and see how the thing reacts. There's certain things out there, certain books for devices where they'll tell you, hey, if you decrease this, it makes it less aggressive. If you increase this, it makes it more aggressive. Sometimes, like RDM, they have it labeled as response on and response off. There is no actual PID. It's just they do, but it's done in a little bit different of a fashion. But as you see, the valve percentage is starting to come down. You'll also notice as the room temperature starts to come down. Right now we're at -4. Let's see what happens when we get down lower than what it's supposed to be. Valve percentage is still coming down. And eventually, never mind, I have it set for supermarket, so I don't know if I don't know if it'll totally shut down if I go way lower on the temperature. I mean, that's all dependent on how you actually have it set up. So we're going to keep coming down and see if it'll actually shut the thing entirely down. We'll see. But over here, click on this section, go to graphs. Now, I haven't learned everything about this yet, but as you can see, it has my room temperature, coil temperature. You'll see in this amount of time it has 6 total defrost. You can actually download this. And right down here you'll see it's saving to a log. If I open that up, it's going to open it up in an Excel spreadsheet. And when it does that, you can actually see basically, let's see, what's this timestamp? Maybe because I don't have the time set. Auxiliary, what it's actually doing. Door switch. And at one point I changed it from door switch to system off, as you can see here. And you can see it went from a 0, meaning off, to a 1. You can see the system off. And then over here, auxiliary 3 and auxiliary 2, which I do not have configured. Coil temperature. You can see where I didn't have anything hooked up. And this is where I started hooking everything up. Same thing with the suction pressure. Same thing with the system mode. defrost, delay, valve position, system messages, alarms. So the alarms that I had, suction pressure, temperature sensor, because I didn't have anything hooked up, and then the only thing that I had was fan and current sensor, showing a fault because it wasn't showing anything because I don't own one. So I can't give the controller, a value as far as the amperage. I'm sure I can come up with something. I just haven't done it yet. Like I said, you can see the valve percentages all the way down to here. So you could actually like I said, you could download this log, send it off in an email, and see if you're having a hard time diagnosing it. You could basically, try to reverse engineer it and see what happened, right? All right, so we're back down here, the graph. This is where it's actually giving the time. As you can see, the time's wrong because currently it's 10 a.m., not 11:30 at night. We go back to here. This is where you can actually set up all your set points. Important settings, I'm sorry. Electric defrost and enabled, main valve. Close that one. Go to refrigeration. Here we have our temperatures, what our temperature set for. Actually, let's go back and see what it's doing currently. Close that up. Home. Let's go back to home. Apparently if the temperature gets too low, see the EEV position finally went down to 0. Liquid line solenoid shut off. The evaporator's still staying on, obviously. Light's going to do whatever I told it to do. Basically, I put in a time schedule, which we'll get to. So we'll go back to set points. Go back to refrigeration. So here we have our whatever our refrigerant set, so it knows to calculate the superheat. Minimum runtime on and off. If you want to make it a dual temp function, you could actually give it, the set point for the low temp and the set point for the medium temp. If you had ECM motors where you could actually give it a signal, you could actually do fan speed, superheat and units, extreme differential units. I'm going to have to look what that is. I'm not really sure. Close that back up and go to main stepper valve. And this is where we have our electronic expansion valve set, our pressure range units. We have the step rate per second, or 200 steps per second for that particular valve. We have the 2,500 steps for total. This is our proportional integral derivative. Basically, this is going to quicken up or slow down our valve, depending on how we have those things set. Defrost, we have it set for electric defrost, so it knows to initiate that relay out. Defrost termination, we have it set for 50. Drain time, 5 minutes. I'm going to increase that. Set that 15. Fan delay units, so that it's not going to allow the fans to come on after defrost until the coil temperature sensor hits 20 degrees. So it's actually using the same temperature sensor here as here, right? Because that's how it terminates and that's how it turns the fans back on. Minimum fan delay time is 2 minutes. So if there's a sensor fault, it's at least going to stay off for 2 minutes before it brings it back on. Electric defrost mode, pulse. I'd probably just do permanent if I'm only doing one evaporator. Pulse is technically for multiple evaporators, so you can try to heat those up evenly. Defrost pump down time, 60 seconds. You can set this to whatever you want. Defrost Q, I don't know. Next mode, this button right here is basically going to switch it from defrost to refrigeration and vice versa. That you can't override anything from this menu. You can override devices, relays from the main controller, but unfortunately you can't do anything as far as overriding the fans, overriding the electronic expansion valve and stuff like that. Defrost demand, which I don't have energized. Runtime defrost, compressor runtime, 6 times per hour. I guess if it would go over that via short cycling, whatever, it would probably let you know that you have alarm. Scheduled defrost per day, 45 minutes, minimum one time. Honestly, I never do that. I usually do about half of what the actual defrost is, or at least close to that. So if it's an odd number, I'll just do like 20. And you see over here, I'll hit save. Saving in process, and it's done. Get out of that menu, go down to alarms. High temperature alarm. You do, usually I do 10 degrees higher than what the set point is. So in this case, I would do -5, or I'm sorry, alarm right away. 5 degrees. High temperature delay, 60 minutes. Low temperature alarm offset. I guess that's 4 degrees lower than maybe what it's set for. Low temperature alarm delay. So 10 minutes when it hits. Door alarm, I would do a lot lower than that. Let's do about 5 minutes. Shouldn't be keeping that door open. Now here you have the fan current alarm and defrost alarm. This is good at letting you know if you have a defrost heater out, if you have a fan motor out, or maybe bound up where it's causing excessive amperage. Same thing with maybe bad bearings. When you first set this thing up, you basically run it through detect current thresholds, and it'll know if it's single phase or 3-phase based off of where they have the actual current sensors. When you run this thing, it can figure out if it's single phase or 3-phase. Alert notifications. I haven't played around with this, but apparently we can send an email. As long as it obviously is connected to the internet, and send an email to whoever, whether it be the store manager, store director, GM, FM, whoever you want. So we're done here. We're going to save whatever we changed. Come down to network. Here's your IP address, subnet mask, gateway, DNS. Username is the KE2 admin. Doesn't really line up for the password that I have to actually log in this. Log into this thing. If you were hooking up via BACnet, so you could hook up to a BAS or EMS system. This is all the information you need. This is where you set the baud rate, your addresses, so on and so forth. Close that up. General information. KE2 solutions, you'd set the location. Rack identifier, what rack you're connected to. Set the manufacturer if you really want to. Equipment model number, just so you have some more data. It'll probably show up on the logging information when you go to download the log. Date and time. We're going to sync that right now. Are you sure? Oh, no, let's not do that. Because right now, if I do sync it, then it's going to delete everything that I just did. Go back to home. And this brings you up to this right here. You can see we currently have an alarm, low air temperature. That would basically tell you either your liquid line solenoid's not shutting all the way or electronic expansion valve. We're basically still able to refrigerate. So if I turn that temperature back up, it should go away. Wrong way. Wrong way. There we go. So we're still at -5, so the EEV is still closed. So is the liquid line solenoid, and like that. As soon as it hit 0 degrees up to 5 degrees, liquid line solenoid came on. See, my EEV position is now starting to rise. Now, if my superheat starts to go really stupid low, it should technically shut off my the expansion valve for sure, and it does right away. So if we have no superheat, it's basically going to clamp down there. Liquid line solenoid is going to stay open. Click on here. I have the lights on at 6 a.m. Off at 7 p.m. Normally on, so you can actually set the state whether you have it wired as normally open or normally closed. So I did not change anything, so it's not letting me know that there's no changes to save. Cancel. Let's go back to this real quick, because I just want to show you this. So we can import or export, which, as you can see, it's now going to save. Let me bring that up here. It's actually going to save the whatever I program this controller for, and that's important because, basically, if I'm doing multiple controllers and multiple cases that are almost identical, I could set all the parameters if I know all the cases have the same stuff on the inside, and then at that point, open that back up, and then basically import. Now it's actually looking for the file that I just put in there, so I can just click on there. Save it. I guess that's it. Just imported it like that. Auxiliary alarm delay. So I can set up for door alarm, permanent defrost, lights. I can set that up for whatever I want. Normally on or normally off. Same thing with the evaporator fan. We have a permanent, managed. I think permanent would probably be with the maybe like clicks on inside the case. But I mean, if you had all these extra controls that you're able to control everything, I don't see the purpose of having an external hardwire control. You have conflicting information of what you're trying to do. Fan on 20 degrees. This is really important when you're dealing with some of the closed door cases, some of the lineups. Sometimes you don't want the defrost relay. Sometimes you don't want the fan relay actually shutting off. This is extremely important when you're dealing with Hussmann RLN or RL case or RLN and RL cases. They utilize for their electric defrost. They use a relay that's powered by on the coil side by the electric defrost heaters. It shares the same power, and basically what that's going to do is switch my power from going to the fans to go over to the pan heater. If we kill the relay for the fans, now we've actually inadvertently caused harm to ourselves, because now what we're doing is we're actually killing power to our pan heater in the bottom of the case. And when you do that, we all know those cases ice up. So just be mindful, of how you're going to have this, based off of how the operation of the case is. Sometimes you have to communicate this to whoever is programming the EMS system, because they might take control over it. Defrost, term temp 50 degrees, drain down time, fan on, defrost. We're gonna just do scheduled. We're still staying with permanent. Parameter 30. I'm not sure what this is. Minimum interval minutes. Oh, that's all for the demand defrost. And here's where our first defrost is going to come into play at 2 a.m. and then from there it's however many. So if I change this to 6, now it's going to be every 4 hours. So make sure that we do save anything that we're doing. Pump down delay, defrost, save. Now right now it's still, if you look over here, it's still in refrigeration mode. If I go back to where I was, if I hit next mode, I just heard the relay click. Defrost delay fan. So the fan is still on. The EEV position is at 0%, and it would go there like I was there before because I'm showing 0 degrees of superheat. But basically, you would have saw the EV position go down. Now, unfortunately, I don't have the expansion board, that got sent to me, so I can't show you like the EEV and the EEPR position at the same time. You can only do that if you have the secondary module. Basically because the EEV now is coming off the main board. So you can see there's in defrost delay. Eventually it will shut off the fan, and then you'll see the defrost come down. It's probably going off of the 120 seconds that we had for the pump down delay. Once again, we don't have any fan current here, defrost current, because I don't have the, oh, there we go, which turned off. So the evaporator fan just turned off and defrost kicked on at the same time. So up here you can actually see what the alarms are. On this particular one, we have a defrost term time, which basically it's terminating off of time and not actually hitting our defrost termination temperature. And that's only because, basically our coil temperature isn't going up because I'm not sitting here during defrost and watching the coil temperature go up. Now I can wrong one, coil temperature. Wrong way. So right now the mode is in defrost. So I'm at 48.8. And right now I have now hit the coil temp of 61 degrees. So once we pass our minimum defrost temperature, theoretically it should kill our defrost relay and then, go into our pump down function. I do these kind of tutorials with the potentiometer so you can actually see in real life what it's going to do based off of the numbers that it's programmed for. This way it helps me diagnose something if I'm trying to do it remotely, or I'm a couple hundred miles away, and then that way I can, okay, that's what it should do when it goes in the defrost, and that's what it should do when when it hits termination temperature or whatever have you. We have auxiliary 1 set up right now as our system off. You can actually change this to whatever you want: defrost lock, quit defrost, light switch, leak detector. So basically you could have a leak detector hooked up to this. You also have 2 other auxiliaries. This one is disabled right now. I could actually have this as a secondary temp switch, door switch, external alarm, maybe like a shutdown. A lot of times you have if it's in a walk-in box, if you have a leak detector go off, basically sends a close set of contacts over to the controller to basically say, hey, you have a leak. I would shut down all the refrigeration. Then you have auxiliary 3 here. And once again, you do have all the same functions. So if you do have some sort of input burnout or whatever, you do have, for the time being, you do have, other inputs that you can change. They are configurable. You aren't just locked in. Now we're still in defrost mode. And there's the MAC address. It's basically like, your home address, right? Basically it's independent. That's what distinguishes this controller from another controller sitting right next to it. The MAC address is always going to be different. Same thing with your computers. So, like I said, I just want to give you a quick rundown, what you're looking at as far as, how to access the controller, how to throw it into a defrost. Guys, thanks for listening, and thanks for watching. Give our channel a like and subscribe to it, and we'll catch you later.